do now this morning. It says state the angles and segments that are congruent in problem 6 through 8. All right, so I'm gonna turn this on here. I use purple. So let's separate these problems. Now, I was saying earlier, you cannot go by the way the pictures look. They have to give you clues. Like for example, they give you the curve right here on D and on angle B. So when you have a single curve like that, and it's the same on the other side, meaning they're both equal and congruent to each other. So angle D right here, because I got one curve right here, is equal to congruent to angle B. That's it. You just go the ones that look the same. Let me erase this. Now, if you look at the two segments, now if you look at the little slash, it's one slash. You have two slashes, and let's give you an example here. If it's two slash here and it's two slash there, they're equivalent to each other. So it's everything that looks the same. That's what you gotta attack. So let me erase this. All right, so let's, now if you look at line segment DC, so put that line on top, is equal and congruent to AB. That's it. Because you see that line right there, line right there. All right, that's it for now. All right, so look at number 7. A lot of people got confused with this, which is understandable. The more practice that you have, the easier it just gets. That's just math in general. So on angle D, same thing here. You got one curve, one curve. So you have angle D is equal congruent to angle B. All right, so that looks good. This. Now let's look at the segments here. You have DC, sorry, not DC, DE is equal to congruent to EB. All right, because the line stops at E here, a line stops here at E. Okay, some students said it's DC, and if you notice, there's no markings there because sometimes in the regions, this could be bigger or this could be smaller. That's not necessarily DC. Doesn't have to be equal to AB. Okay, but if you wrote it down, I'll give you credit for it. Also, because this last one here, there's two ways to write angles in 6 and 7. I could also write the angle as angle ADC, which is here, ADC. That's the angle right there, is equal congruent to ABC. You'll see why I discussed that in a second. So ABC right there. Now, the reason, remember what I discussed in class, the letter that's in the middle, when you start from one endpoint and you follow through to the end, the letter in the middle is the angle. And if you look at number 8, you can see we can't use a single letter because the single letters are sharing two angles. And that's why I'm discussing that right now. And same thing with number 7. Number 7 is in the same, you could also label it as in an angle ADE, angle ADE is equal to and congruent to CBE. And let me make sure I put my angle measure right here. Okay. And then let's look at number 8 because now we can't use a single letter because it's they just talk about angles there. So let's look at the single curve right here. So I'm going to attack ADB. So angle ADB is equal and congruent. And you look for the single curve, which is at DBC right here. DBC. So DBC is at that angle. Okay, and then if you draw this angle, the ADB, you see it right there in the single one. It's all it's a little abstract. It's a little a lot of people. There's a lot going on, so you just gotta focus. I focus one thing at a time. Now let's look at the double curve, which is at um, CDB. So angle CDB, because now if you notice it has that double, it has two curves. And I gotta find another one that's equal and congruent to it and it has a double curve, which I will go ABD. ABD. Again, you follow one endpoint and you do this in a different color. You follow one endpoint and you follow through, which I noticed there's two slashes right there. So two slashes. Okay, they're equal and congruent to each other. And that's the first part. Yeah, that's it. All right, let's go down. So we discussed this morning what angle bisectors are. And some people were confused. There's a lot in the pictures, there's a lot going on, but just remember the angle bisector, underline it here, the angle bisector cuts an angle exactly into congruent halves right here. And you focus on this angle 1, angle 2, and then your angle bisector, it's right here. When you see those two slashes. Okay, now let's see what this is saying right here. Let me erase this. Now it says angle EBF, EBF. So you focus on this angle right here. Focus on that right there. Okay, is equal and a half of ABC. So A. Do some different color. A, B, C. Okay, now I'm gonna color this. They said a half of the bigger angle. What's that? So I'm gonna shade one half is equivalent to that half. Is that true? Oh, by the way, we're looking for what's not true here. So to try and find the diagram above shows the construction of bisector of ABC, which statement is not true. So this is equal to that because half of the bigger angle, and they gave you half of the other one. So that works out. The wording on this is tricky because of the knots and the halves. So you gotta be careful and lots of practice is recommended. Okay, so now let's look at D angle DBF. So DBF. Okay, so that's half right there. It's half of the angle. And then is it equal to, let's make this a different color. Make it blue. A half of ABC. So it's A, B, C. So that's the bigger angle. And they said half of that, which I'm going to shade that. We only need to shade one half. Okay, that's exactly what it says, half of ABC, of that big. So of the bigger angle right here. So this side is equal to that side, so that checks out. Let me erase that. Now look at EBF. So you got E. Oh, come on. So you got E, B, F. Okay, so they're looking at this angle right here, like right at the B. Is that, sorry, right here, EBF, is that equal to a different color? I keep forgetting, sorry. A, B, C. And I don't see a half or anything, so I'm gonna shade the whole thing. So is that bigger angle equivalent to half of that angle? And the answer is, this is the not. So the answer is choice 3, but let's see, let's check the last choice. DBF. So you got DBF. Okay, so that's the half of that angle right there. Remember, an angle bisector divides into 2 equal parts. All right, 2 congruent parts. So that's my angle right here. That's one side there. And then is that equal to angle EBF? So it's, do a different color. Use purple. EBF. And that's half of that. And that's also true. So only one that's not true is 3. Okay. I'll go over the last one. Let me clear all this. Actually, I don't need to clear all of it. Let's scroll down. All right, so this is the formative assessment that you guys did today. And I'm going to do the whole thing in its entirety. The one above, the one on top, I forgot to answer the question. So on this one, I will answer the question the way they want you to see it on the regions. Okay, so these questions, the way it's worded could be a bit tricky. So let's see what it says here. All right, so it says, based on the construction below, which statement must be true? So now is A, B, D, A, B, D. Okay, so it's the angle bisector again. So we know these 2 angles are cut in half. So ABD, okay. Is that a half of CBD? So we got half here. So what this is saying, CBD, I'll use the highlighter. All right, CBD, but they're saying it's a half of CBD, meaning it's the angle is the half of this right here. That's what that means. Is that equal? No. See, the wording could be a bit tricky. You have to translate all these. Now let's look at, let's see, I'll use this one. Now is A, no, that doesn't work. Is A, B, D, so A, B, D, okay? Is that equal to CBD? I'll use a different color, I keep forgetting. Use blue. CBD. So is this angle equal to that angle? Yeah. I'm leaning with choice 2, but I'm gonna look at the others just in case if I mess up somewhere. Now let's look at number 3. Let's stick with blue. I like that color. Must be true here. All right, so now ABC, A, B, C. No, I messed up. I read the letters wrong. All right, sorry. Sometimes that will happen. Let's reset. ABD. So A, B, D. Okay, so we're looking at that angle in blue. Is that the same angle measure of ABC? So the bigger triangle, let's make it orange. A, B, C. And if you look at the angle here, that's the whole thing. So no, that can't be it. Now let's look at CBD. CBD, you look at the angle right here. Is that equal to a half of A, B, D? And what that's saying is it's a half of the angle here. Is that equal? I said no. So the only answer choice is 2. Okay. And it says choose why. Explain why you choose your answer based on the diagram. So now, once you see the slashes here aligned, it's an angle bisector. That's what I mean when you see that. When you see that coming out, we see those slashes, it's some type of angle bisector that divide this in half. So, let's say, so angle B, you know what, BD is an angle bisector. Bisector. Oh, I ran out of room. This is right here. Angle bisector. Okay. Now, with that definition here, so we know 1/2 measure A, B, C as equal to angle A, B, D is equal to angle DBC. Because that's the definition of an angle bisector, is to divide, is to break these two angles up into two equal pieces. I hope that helps. I know it's confusing with the wording and the definitions. And if you have any more questions, you guys could write to me in the chat on YouTube or on in your Google Classroom. All right, it's getting late. Have a great night.